Hello everyone, I welcome you all in the course Introduction to Sequence Stratigraphy, and we will continue our discussion on the types of surfaces that form in sequence stratigraphy, that we deal in sequence stratigraphy. And under this particular category, today in this particular lecture, we are going to discuss about another very important surface which forms during the base level fall, and the name of this surface is regressive surface of marine erosion, abbreviated as RSME. So, in this class we are going to discuss about the different aspects of this particular surface RSME. So, the regressive surface of marine erosion, it forms during the force regression, commonly in wave dominated shelf settings. So, we require little bit higher wave energy condition for the development of this particular surface. So, where the seafloor gradients are relatively low and they are in balance with the wave energy, resulting in continuous wave reworking of the sea floor. So, very often this particular process is called as regressive wave refinement process, and this wave refinement process associated with regression leads to formation of this particular surface called as the regressive surface of marine erosion RSME. So, this refinement surface is basically a scour, that scour cut by the waves in the lower surface during the base level fall, or it can continue even up to the shelf, where the surface or the shelf area that attempts to preserve its concave profile, which is in equilibrium with the wave energy. So, this battle, this balance between wave reworking along the wave equilibrium profile and the substrate maintaining its profile, the concave profile, which is controlled by the amount of sediment coming into the system. So, these two controls whether there will be finally erosion or there will be accumulation of sediment. When accumulation of sediment takes place, we have already seen in our previous class, we get the preservation of or deposition of the falling stage system strat with preservation of the original substrate, which we call as the BSFR. But when the sedimentation is less with respect to the wave reworking, with respect to the wave equilibrium profile, or in other words, when the wave equilibrium profile is more steeper than the substrate, in those cases there will be reworking of the substrate and a new surface will form, which will be called as the regressive surface of marine erosion. So, how we can define this regressive surface of marine erosion? We can understand this by drawing a simple diagram. So, we are referring back to the same marginal marine condition. This is the substrate at the start of the fall. So, the base level was at level 1, and from there the base level is coming down to level 2 like this. So, for this level 2 we are getting new wave reworking, and maybe because of this fall a new wave equilibrium profile is formed. So, this particular line is the wave equilibrium profile for level 2 of base level, which is cross cutting over here, cross cutting the substrate. The original substrate was here, this is the original substrate. So, it is cross cutting over here. So, this wave energy will erode the sediments from here, and we are getting this new substrate now available. So, from this point onward we are getting this new surface, which is called as the regressive surface of marine erosion. So, this regressive surface of marine erosion is formed due to this base level position 2. Now, this is the equilibrium condition. So, for this particular condition we are getting a deposition of sediment over here, up to this much of sediment is deposited here, which is an offlapping sediment, which is a FSST sediment. Now, the base level is coming down to level 3. See, for example, it is coming down over here. So, for this level 3, when it has started from level 2 to level 3, for the level 2 the substrate is this one, and from there now the base level is further falling to level 3. For this level 3 we have a new wave energy condition, and that wave energy will lead to a new equilibrium profile, that will lead to a new equilibrium profile, wave equilibrium profile like this. So, we are getting a new lever point formed over here. So, this much of sediments which were preserved, which were deposited under the previous condition will remain preserved, will remain accumulated, but this will be eroded, and we are getting a new erosional surface formed over here. If earlier one was the RSME 1, so this is the new erosional surface, so this is RSME 2. So, after some time what we get, this is the original surface BSFR was preserved, then we get a new surface formed which is an erosional surface. So, this is RSME surface. For the next phase of fall we get another RSME surface, and in that way it can go on. So, for each of them these are the overlapping packages. So, this surface is RSME surface, this surface is RSME surface, and finally, if it is ends with this, this is the correlative conformity surface, which is the end of the fall. So, all these previous erosional surfaces which are preserved, they are the RSME surfaces or regressive surface of marine erosion, which is indicating this wave equilibrium profile with respect to the substrate position. So, in this way multiple RSME surfaces can form during this force regressive phase. So, definitely this package will form in the marginal marine to shallow marine part. Definitely it will not cover up within the continental part, it cannot form, it cannot get preserved in the continental part where fluvial incision is going on. So, the name itself indicates it is the regressive surface of marine erosion. So, it is about the wave refinement process, wave erosion process. The process of wave scouring is only possible where the seafloor gradient beyond the toe of the shore face is lower than the gradient of the wave equilibrium profile, as we have seen in this diagram, which is approximated by the seafloor gradient of the shore face. So, we can expect what is required over here is relatively high energy wave conditions which can rework the substrate, which can rework the seafloor itself. This condition is fulfilled in most of the wave dominated shelf settings where frequent storms, they can come over and they can affect the overall substrate, overall shelf area, and those high energy storms which are nothing but high energy waves can erode the substrate condition. So, in a wave dominated setting, the BSFR and the RSME, the original substrate and the new substrate formed by this erosion, formed by this equilibrium, they meet at a lever point which you can call as the onset of fall lever point. When this fall is starting, at that point we get a balance between the start of the fall, start of the base level fall, with respect to that the equilibrium profile of the waves and the substrate, the sea floor. So, this original sea floor and the new equilibrium profile of the wave, they will meet at one point which is the lever point, this already we have discussed, and that is the onset of fall lever point. And as the erosion will continue in successive phases of base level fall, there can be multiple such lever point which will gradually shift towards the self direction. So, that lever point indicates the balance between upper shore face sedimentation and the lower shore face wave scouring, or when we are moving into the self part, that will indicate the balance between the lower shore face and the self wave scouring. So, in that way gradually the balance goes on changing, goes on shifting its position with changing position of the lever point. So, the position of the lever point will determine that what will be the length of the BSFR, and followed by that how many RSME lines are preserved in that particular succession. So, if I draw this one, say this is the shore face area, this is the HST part, and for this particular base level we have wave equilibrium. So, it is going on like this. So, in this position wave is reworking and it is allowing sediments to accumulate over here. So, this particular surface is the BSFR surface and this is the lever point. So, below this what is happening? The wave equilibrium is cross cutting the substrate. So, it is the new surface formed over here. So, this part is the RSME, a new RSME is forming over here. So, this lever point is the transition between, or rather the contact point between the BSFR in the landward side or in the salomarine part and the RSME which is forming in relatively deeper part, relatively distal part. For the next phase of the fall, we get this new base level and for that we get a new equilibrium profile and we are getting a new lever point. So, this is lever point 2 which is forming over here. So, this lever point is further controlling or is producing a new substrate, a new erosional surface which is the second RSME surface. So, in that way we can get multiple lever points which will gradually shift, indicating the shift in this balance of sediment supplied, accumulating and the erosion going on over here. So, that erosion by wave refinement process will produce new erosional surfaces. So, definitely when we are going away from the shore for erosion over here, say for example, if this is the shelf environment, so we require high energy waves to come over here. So, commonly that comes with storms, marine storms. So, very often this kind of surfaces, formation of this kind of surfaces are associated with storm led shelf deposits. So, in settings where the sea floor beyond the fair weather wave base is relatively steeper than the wave equilibrium profile, for example, in the river dominated deltas, in such cases more sediments are accumulating and the clinoforms are relatively more steeper, and in such cases the continental slopes or the sea floor, its slope, it commonly is more steeper with respect to wave equilibrium profile. So, when the base level is falling, in such cases it is not accompanied by wave scouring and in such cases the wave refinement surface is not formed or is not resulted in. So, these are some special cases. This also we have discussed during our discussion on BSFR. So, when we get such kind of condition that the huge amount of sediments are supplied into the system which is overpacing this reworking by the waves. So, in such condition what we can expect is the wave reworking is not able to cross cut the substrate now, because the substrate, its profile is more steeper because of more accumulation of sediments, and as a result of that wave equilibrium profile is not cross cutting through the lever point. So, in such cases formation of the RSME surface is not possible. We can get the BSFR surface preserved only in such cases. So, in a river dominated deltaic setting, which is the most ideal example for this kind of situation, where lot of sediments from the river is coming into the system and producing a very steep angle of repose of the prograding clinoforms. In such cases, the wave equilibrium profile is gentler with respect to the prograding clinoforms and no wave scouring affects the sea floor during the forced regression. So, as a result of this, the forced regressive surface deposits are gradationally based in this kind of conditions, when the sediment supply is more than the wave energy available in that part. So, RSME will not form in those kind of conditions. Say, if I just try to draw it over here, if you are getting a river dominated delta, so you are getting lot of sediments are coming in and they are offlapping, producing this kind of steeper clinoforms. So, for level 1, level 2 like this. So, base level is falling in successive stages, and for that we are getting accumulation of prograding delta lobes which are producing steeper clinoforms, and with respect to that the wave equilibrium profile, the wave reworking which is going on at an angle like this, at a profile like this. So, this wave equilibrium profile is not cross cutting this substrate. So, the new substrate is this. So, always we have this much of space available for the accumulation of sediments on the earlier substrate. So, the earlier substrate is preserved and we are not getting RSME surface formed over here in this kind of conditions. So, in this kind of condition, this entire surface is actually the original substrate, the BSFR. So, this is one such example. Whenever we get more steeper wave equilibrium profile and it is cross cutting the substrate, we will get the lever point and from there on we will get the RSME surface. So, whether or not the force regressive self deposits are preserved during this storm waves covering, this high energy waves covering, the RSME surface, the erosion caused by these regressive wave processes producing this new surface is always placed between the self facies at the bottom. It can be part of the normal regressive part, normal regressive package, part of the HST, or it may be part of the force regressive package which has formed just before that. And the overlying part is always the shore face deposit as the system is moving forward, moving towards the sea, towards the distal part. So, shore face facies will come over the self deposits. So, in this kind of condition, when we are starting from here, the underlying part is always the HST part. But when we are getting erosion like this, in this case, this HST even may be eroded partially. For example, over here, when we are getting a deposition like this, or maybe we are getting a profile where the wave equilibrium profile, say this is the falling stage deposits that have formed, and then we are getting a new wave equilibrium profile which is eroding like this. So, this substrate which was formed during the last force regressive phase, during the early phase of the force regression is now getting eroded. So, below this what we are getting is the FSST package, whereas in the top part always it will be covered up by the shore face which are coming from the landward side, from the shallower part, it is covering up. And when this falling phase will stop, when this falling phase will over, it will be ended up with a correlative conformity surface. So, in terms of the package of sediments, it can vary. When we are looking into the self area particularly, where more frequently we get this RSME surface to be preserved. So, there what we expect is the self faces always lying below this surface, that self faces may be part of the previous normal regressive package, the HST package, or it may be part of the force regressive package formed during the early phase of force regression. And this RSME surface, which is an erosional surface, will be overlain by commonly the shore face facies, which is the force regressive package formed during the late phase of force regression, or maybe the normal regression during the next LST package. So, it can be either of these, but normally it is a shore face facies. Whenever we get that kind of scenario, that kind of packages, this erosional surface is associated with strong erosion of the earlier sediments, and that erosion is represented in terms of several erosional features, for example, gutter casts. So, very often as the waves covering, it is associated with very strong waves, very high energy waves. So, often the overlying sediments are hummocky cross stratified sands, and the base of those hummocky cross stratified sands, they are associated with gutter casts. So, within an overall fine grained succession, we can expect this kind of hummocky cross stratified sand with gutter cast at the bottom of this kind of successions, indicating the regressive surface of marine erosion, which indicates there was a base level fall accompanied by sea floor scouring, and that reduced the accommodation, and we are getting a force regressive package formed over there as part of the self storm deposit. Above the RSME surface, the prograding upper to middle surface deposits, they are commonly associated with soily cross stratified units, soily cross stratified surf based sands. Most of these surf based surface sands, they are commonly associated with the normal egressive lobes, which accumulates on top of the seawardmost part of the regressive surface of marine erosion. So, as the LST package starts, as the sea level starts rising, so we get extra accommodation space and accumulation of sediments under high energy waves that starts over there, and we get this kind of progradational packages formed over there on this RSME surface. So, this RSME surface forms continuously in successive phases and they gradually expands basinward during the base level fall. As we have seen, it can start with a BSFR at the bottom and then we can get first RSME followed by the next RSME followed by the next RSME, and it can go on like this. So, successive RSME surfaces can form which can gradually prograde basinward during successive phases of base level fall. So, RSME surfaces, they are time transgressive in nature and definitely they are highly diachronous in nature, because that diachronous nature is because of varying sediment supply and varying amount of erosions across the shoreline at different parts. Different parts of the shoreline behaves in different ways during the forced regressive phase, depending on what is the energy condition, wave energy condition, what is the gradient, what is the sediment supply. And accordingly, we can get the formation of this RSME surface in different parts of the basin formed at different times when we move along the strike. So, it is a highly diachronous surface. The RSME surface, they forms through truncation of the older clinoforms, and these are commonly downlapped by the younger clinoforms which are prograding during the next phase of the forced regression. So, these prograding clinoforms, the prograding surf based shore face deposits, they produces this package above the RSME. The RSME surface cuts across the shallow marine forced regressive succession as they are successively forming one after another, and finally they can merge with the correlative conformity surface in a basinward direction. So, when this final erosion is over and the base level fall phase is over, it will end up with a phase of deposition which will mark the correlative conformity at the top of that package. So, the RSME surface will merge with that correlative conformity surface in the basinward direction. So, this RSME surface, they commonly form within the forced regressive package. As we have seen, the underlying package, it can be a forced regressive package, as well as the overlying package, it can be also part of the forced regressive package. So, very often we get this RSME surface preserved within the same system struct, falling stage system struct. So, in such cases, it cannot be used as a system struct boundary or it cannot be used as a sequence boundary. But in many other cases, RSME surface can act as the boundary for the entire forced regressive package. Below is the HST package and overlying it is the FSST package. In such cases, RSME surface can be used as the boundary for system struct, and if it can be correlated with the unconformity, it can be used as the sequence boundary as well. So, we have to be bit careful when we are identifying the RSME surface. We have to be careful in terms of what are the packages lying below and above the RSME surface. We have to be careful that how many RSME surfaces are preserved in that succession, and based on that we have to determine whether a particular RSME surface is qualifying for being a system struct boundary, or it is a sequence boundary, or it is not a system struct boundary, it is just a within trend contact. It is just representing the contact between successive packages within the forced regressive self deposits. So, it is one of the most prominent sequence stratigraphic surface as it is represented by erosion with a strong physical expression in the rock record due to the contrast in phases across the scoured contact. In the lower part, we get normal regressive HST self deposits, overlying part is normally the forced regressive short phase deposits. So, very contrasting phases types across this erosional surface. However, in both the cases, lower one is a normal regressive package, so it is a coarsening upward, upper part again a coarsening upward because it is a forced regressive package, but the nature of phases, the depositional systems, they are different and they are quite contrasting with respect to each other, which can be very easily identified. The process of wave scouring during the forced regression can lead to exhumation of some part of the sea floor, and that can lead to formation of some semi-lithified sediment beds. So, such semi-lithified sediment beds can result in the formation of farm grounds, where we can get glossy fungites ichnofacies. So, presence of such farm grounds separate the deposits with contrasting ichnofabrics, largely due to the abrupt shift in the environmental conditions which prevailed during the deposition of the successive phases across that particular contact, that RSME surface. So, if I now want to conclude over here, so RSME surface, another very important erosional surface which forms during the base level fall. So far we have discussed about 4 different surfaces which forms during the base level fall, starting with unconformity, correlative conformity, basal surface of forced regression, and this one, the regressive surface of marine erosion. So, at this point I would like to just give you an overview of how these 4 different surfaces are identified or they may occur together in a marginal marine setting, in a shallow marine setting, particularly when you are looking into a wave dominated marine setting. So, we are again coming up with a continental part where a river system is there, and then we are looking into the basin part where we are getting the shore area and the shelf area. So, when the base level is falling, say if this is the base level and it is falling from level 1 to level 2. So, for this base level fall, it is coming over here. So, the first change that we will get is the river profile will change up like this. So, there will be river incision or river bypass, and as a result of that we get an unconformity formed over here in this area. This unconformity will continue with successive phases of fall, where we get this kind of forced regressive offlapping packages, which will result in with further fall in the base level. So, for final stage of erosion, what we are getting is this particular surface continuing up to this and this kind of offlapping package on the top part. So, this is a truncation surface which we commonly call as the subaerial unconformity. Now, when this subaerial unconformity is forming in the marginal marine part or in the continental part, at the same time in this area we are getting this wave reworking, wave equilibrium profile is forming, and it is cross cutting the sea floor. So, for this first level of fall from level 1 to level 2, we are getting a new wave equilibrium profile. So, this new wave equilibrium profile is cross cutting over here. So, this part of the area, this part of the basin is accumulating sediments and we are getting a conformable succession. So, this surface is the BSFR surface, which is representing the original surface, original substrate at the start of the base level fall. Beyond this point, which we call as the lever point, we are getting a new substrate formed. Now, this erosional surface, this wave equilibrium will have some limit. So, if we can consider over here, if this is the continuation of the self, maybe this equilibrium profile is going on like this. So, below this point we will again get a deposition. So, this is the BSFR surface again, which is preserved in the self area, and on that we are getting a new erosional surface. For this next phase of fall, what we are getting? A new erosional surface formed like this. So, we are getting another surface formed over here and another deposition formed over here. So, eventually successive overlapping packages separated by erosional surfaces. So, those erosional surfaces are producing a new substrate at the bottom. So, these are all downlapping packages, and finally, if this is the last phase of base level fall, this is the end of the base level fall. So, what we get is, for this level we get a deposition. So, we get this much of deposition formed over here. So, this surface, this particular surface is equivalent to this last phase of erosion. So, this top surface is called as the correlative conformity surface, and this underlying surface, which is the new substrate formed by this erosion, successive phases of erosion, these are the RSME surface. So, if I make a log somewhere here in this point, what I get is the HST package, which is a coarsening upward succession, and that coarsening upward succession is truncated by subaerial unconformity. So, it is the erosional phase. So, no deposition is occurring over here. If I want to make a log somewhere here in this part, it is the again the HST package, which is a coarsening upward package, and it is a conformable contact now on which we are getting a forced regressive package. So, this is the HST package, on that we are getting a forced regressive package, and that forced regressive package is truncated by subaerial erosion. So, this surface is the BSFR surface and this is the unconformity surface. In between we are getting the falling stage system strat, which is overlying the HST. If we are making a log somewhere here in this part, so what we are getting over here, again similar kind of HST, which is a coarsening upward package, followed by a conformable surface, which is the BSFR surface. Above that we are getting a very small package of falling stage, and that is overladen by a new erosional surface, which is the RSME surface. Now, this RSME surface is actually coinciding with this final erosion, so it is overlapped by the unconformity. If I make a log somewhere here in this part, what we are getting? We are getting an HST package at the bottom, which is a self deposit. On that self we are getting the BSFR, the original surface, the original substrate preserved. On this self again a coarsening upward self deposit is coming up, and that self deposit is eroded with a new surface, which is not the unconformity surface, but this is the RSME surface. On this RSME surface we are getting another self deposit, and this self deposit is marking the end of the deposition at the end of the forced regressive phase. So, this surface is the correlative conformity surface. So, in this way, within the same basin, starting from landward side to the selfward side, we can get different types of packages separated by these different surfaces at different areas. So, all of these surfaces may form at different phases of base level fall, depending on the control factors like the amount of fall, how much is the base level fall is going on, associated with that how much is the wave energy condition that is controlling what is the slope of the wave equilibrium profile, and what is the profile of the, what is the gradient of the sea floor, how much is the sediment supplied into the system. So, all these factors together will control what will be the nature of accumulation and erosion, and finally based on that what will be the nature of surfaces formed in different parts of the basin. So, I hope that this discussion will be helpful to all of you. So, for further reading you can go through these references. Thank you everyone.